In this video, I'm going to talk about the solubility of different solutes in solvents when making solutions. For calculations such as molarity, to calculate the concentration of a solution, I have a separate video for that. You can check in the description and scroll down and you will see solutions and you will see the different topics under that. In this video, we're going to talk about solubility, how well something dissolves. So we've got to remember the two parts of a solution are the solute, the thing you're dissolving, and the solvent, the thing it's dissolving in. So if you put sugar in your tea, the solute is the sugar, the tea is the solvent, and the solute dissolves and comes apart, maybe, or in the case of sugar, it stays together, but it mixes with the water and you have it all dispersed through the solvent to make a solution. So a solution is the solvent, that liquid, usually a liquid, and the solute particles all be distributed evenly in that mixture. You can always separate it back out by evaporating your solvent, and you'll be left with your crystals of solute at the bottom. That's how you make rock candy. Different substances have different solubilities in water. We're going to mostly be talking about water here. And so there are rules to help you determine how soluble a particular solute will be in water. So on the left of this chart, we have soluble compounds. That means they dissolve. Exceptions will be things that do not dissolve. So our first rule is that alkali metals, that's metals in the first column of the periodic table, they are soluble. So if you mix them with something else like sodium chloride or sodium nitrate or lithium bromate, they will dissolve. The second rule is that ammonium compounds, when you look at the formula, if you see NH4 in the front, it is going to dissolve. So these two rules are the ones that are always soluble to some extent, enough that we say that they will dissolve. And we're looking at ionic substances here in these solubility rules. If we look at nitrates, acetates, and chlorates, and perchlorates, they are all soluble as well. So that's looking at the negative part of the atom. The first two are looking at positive ions, and all the rest are going to be looking at negative ions called anions. These four are soluble, so they dissolve as well. Now we start getting into the ones that are soluble except with certain things. So there are some that are soluble and some that are not soluble. So you always need to check your exceptions when you're looking at these particular ions. Chloride, bromide, and iodide, which are here, here, and here, these three halogens, they are pretty soluble with most things unless it's with silver, lead, or mercury. If it's with silver, like silver chloride, that is not soluble. And that will just settle to the bottom of your container and it won't dissolve in the water. Sulfates. If it's with any of these, it's definitely soluble. But if it's with any of these, it's not soluble. I don't know why they have silver twice. With a sulfate, you need to check your front ion. So if it's something like calcium sulfate, it is considered to be not soluble. So very, very, very little of it will dissolve. It will pretty much fall to the bottom of your container. And then there are some things that are not soluble. These are our insoluble compounds, carbonates, chromates, and phosphates. However, now this is backwards of up here. These were the ones that did not dissolve. Now it's saying these don't dissolve and these are the ones that do dissolve. But notice that's just our first rule and our second rule. These three things don't dissolve. They're insoluble unless one of the first two rules applies. These are pretty much in order, with these being priority. So anything that has an alkali metal in the front is going to dissolve, even if it's with a carbonate or a chromate or a phosphate. Hydroxides and sulfides, same thing. Again, we have our first column of our periodic table. Our alkali metals are soluble, just like we said up here. There are also some metals in our second column that are also soluble, and those are calcium, strontium, and barium. So those are these three: calcium, strontium, and barium. These three are soluble with OH and S negative ions. And fluoride is insoluble, so you don't have to worry about that. Put it with one of these, it will be soluble, but otherwise, no. And remember, solubility, soluble means dissolves, insoluble means does not dissolve. So we can look at solubility charts, and they look like this. Notice that on the left side is our solubility, and it's the grams of the salt, the solute, in 100 grams of water. How much will dissolve in 100 grams of water at different temperatures? So temperature affects solubility. Notice that for these salts, with the exception of this one, all the rest increase as the temperature increases. They increase. They're going up as the temperature goes up. So you can answer all kinds of questions from using this type of chart. If it's in 100 grams of water, then you can just use the chart to answer the question. Here's a typical problem that you might see. How many grams of KCl can be dissolved in 100 grams of water at 40 degrees Celsius? Since it's in 100 grams of water, we can just find the answer on our chart. We're going to be at 40 degrees. We want to go to 40 degrees, and then we're going to read up until we hit the line, which is KCl, which is right there. And then we read across to find the number of grams, which looks like this is 30, this is 40. So it looks like maybe 38, 39 grams of KCl. For our second problem, we're asked, at what temperature will 30 grams of KNO3 dissolve in 100 grams of water? Again, 100 grams of water, so we can use our chart. We want to look at our KNO3 line, which is this one, and we want to find out when 30 grams will dissolve. So here's our grams. So we're going to go across at 30 until we hit our KNO3 line, which is this one. And then we're going to go down to see what temperature it was when that happened. And we were at 20 degrees, so 20 degrees Celsius. You can see how this chart will be very helpful if you're asked for how many grams can dissolve or for the temperature, grams or temperature. And as long as it's in 100 grams of water, you can use this chart. Well, what do you do if it's not in 100 grams of water? For problem 3, we're asked how many grams of KClO3 can be dissolved in 40 milliliters of water at 30 degrees Celsius. So now we have 40 milliliters of water. That's not 100. So we're going to use a ratio to figure this out. The first thing we're going to do on our ratio is figure out, well, what if it was 100 milliliters of water? How many grams of this could we dissolve in 100 milliliters of water at 30 degrees? So we're going to go to 30 degrees, and we're going to go up to KClO3, which is this line. And at 30 degrees, looks like we're right there at 10 grams. So if we can dissolve 10 grams of KClO3 in 100 grams of water, how many grams can we dissolve in 40 milliliters of water? Notice I kept my solute on top, my solvent on the bottom. This side of my equation came from my chart above, right here, using this, and this pertains to the problem, and you're going to do this whenever it's not 100 milliliters of water. So we're going to cross multiply. 10 times 40 is 400. X times 100 is on our other side. We're going to divide both sides by 100 to solve for x. So our x is going to be equal to 4. So 4 grams of KClO3 can be dissolved in 40 grams of water at 30 degrees. Now, I pointed out that salts tend to increase as our temperature increases, the solubility increases. But look at NaCl. It's this line right here. Notice that from freezing of water, 0, it's about 35, all the way up to boiling of water, which is 100, it's about 40. It barely changed. It's pretty level compared to everything else. And this is the main salt that you find in the oceans. And this is a good thing, that it stays pretty constant with its solubility. So when it's in the polar regions, the salt doesn't come out, it stays dissolved. And when it moves toward the equator, where it's warmer, it stays dissolved. So it's pretty level here. Otherwise, every time the currents, the tides took the water up to the north and south poles, all the salt would fall out because it wouldn't be soluble, and it would leave all the salt at the poles, and then it would come back down, and it'd be way closer to being fresh water when it came back down, and that would have a huge effect on all of our ocean life if that happened. The last thing I want to address is what happens when you have these curves where it's not going up. They're coming down, like this dark blue and this lighter blue one. The dark blue one is NH3, which is ammonia, which is a gas. And SO2 is also dropping, and SO2 is also a gas. So while solids get more and more dissolved at higher temperatures, gases have less dissolved at higher temperatures. Now, this can be a problem in a pond. If it's 40 degrees in the pond, oxygen is dissolved in there for the fish to breathe. If it's 40 degrees, they'll have a certain amount of oxygen dissolved in there. In the summer, as the temperature of the pond increases, then the solubility decreases, and there's less and less oxygen in the summer than there was dissolved in that water in the winter. That's one of the problems with climate change. If the earth is getting hotter, then the bodies of water are getting hotter, and they're holding less oxygen for insects and fish and other things that actually live in the water. This is a graph that shows the noble gases. So the noble gases are over here: neon, argon, krypton, xenon, radon. And notice that as the gas gets bigger, it's a little bit more soluble. Now, this solubility is very low compared to the solid solutes. Gaseous solutes have a much lower solubility, but notice that all of them are dropping as the temperature increases. Here's some common gases that you might see. CH4 is methane, O2 is oxygen, carbon monoxide, and helium, which we saw on the last graph, was relatively stable. You can see helium here is relatively stable as you go across. So oxygen, which would really affect our fish at 10 degrees, you have a much higher solubility than you do at 40 degrees Celsius, which is, remember, water freezes at 0, and so it's decreasing. 40 degrees is not super hot. Water boils at 100. The human body is 37 degrees Celsius, if that helps you visualize this. So just above freezing, it's way up here, and when you get to body temperature, it's way down here. So it's decreasing the amount of oxygen that will stay dissolved in your water. That's it for solubility. If you'd like to see how to figure out concentrations of solutions, then watch the molarity video, and that is linked in the description. I hope this has helped, and check out my other chemistry videos. Please like and subscribe. Have a great day.